Welcome to the SmartKeys podcast. Imagine launching a multi-million-dollar AI hiring tool for your company, only to discover on day one, that you've accidentally automated and scaled gender discrimination at like light speed.
Yeah, which is just a terrifying thought.
Right. And that isn't a hypothetical. That actually happened to a major tech organization. So today we are doing a deep dive into how you prevent those massive systemic failures.
Exactly. Because it's happening a lot more than people think.
It really is. We're looking at this incredibly practical resource today. It's an article by Felix Römer titled AI Ethics Framework for Responsible and Fair Decision-Making, and you can find that straight on smartkeys.org.
Highly recommend it for anyone in the space.
Yeah, totally. And our mission for this deep dive is to bridge that massive gap between, abstract, high-level AI policies and the actual daily practical code being written by engineering teams.
Right. The stuff people are doing on the ground.
Exactly. If you want to understand the future of work, business efficiency, and how to build systems that people actually trust, this is your strategic roadmap.
What's fascinating here is that the transition from theory to practice is where the entire industry is currently bottlenecked. I mean, organizations completely understand that they need guardrails, right?
Sure.
But when they try to implement them, the engineering teams just freeze up.
Yeah.
Because the instructions they're getting are completely fragmented.
Oh, the scale of that fragmentation is wild. I mean, Rumor's article notes that researchers cataloged 47 separate AI principles across 6 major global initiatives.
Yeah, 47. It's too much.
It's way too much. Building an AI system today feels like trying to assemble an airplane mid-flight while 47 different international aviation authorities are literally shouting overlapping blueprints at you.
Right, yeah.
It just creates a sort of principle proliferation that slows innovation down to an absolute crawl.
Well, and the thing is, overlap is actually a very normal feature of a new technological frontier. You have, dozens of regulatory bodies, academic institutions, corporate consortiums, all trying to establish the rules of the road simultaneously.
Makes sense. Everyone wants to say.
Exactly. But the trap for a modern professional is thinking you have to perfectly apply all 47 blueprints. That will just paralyze your development cycle entirely.
So what's the fix?
The solution is to normalize that baseline. You map those overlapping instructions into a synthesized set of core values.
Which is exactly what Römer does. His synthesis takes all that noise and distills it down to 5 core principles. But, looking at them, I immediately see a massive practical tension.
No, definitely.
You have beneficence, right, which is this mandate to maximize good well-being, operational efficiency. But then the very next principle is non-maleficence, which is all about minimizing harm, locking down privacy, and building threat models.
Yeah, they pull in opposite directions.
Completely. If I'm an engineer writing code, those two are constantly at war. Every new capability I build to maximize good inherently creates a new vector for potential harm.
And that tension is exactly why a framework is necessary.
Right.
Without it, engineers are just guessing where the acceptable line is.
Right.
Non-maleficence forces you to build threat models before you write the capability. You don't just ask, what happens if this works perfectly? You actively engineer for what happens when a malicious actor tries to break this.
Which is a huge mindset shift.
Totally. Then you bring in the third principle, justice, which requires measuring fairness across different demographics so the model doesn't just, optimize for one group at the expense of another.
Yeah.
And fourth is autonomy, ensuring humans retain the ultimate authority over when and how decisions are delegated to the machine in the first place.
Okay, let's unpack this. Because I want to stop on the 5th principle, explicability. I totally misread it at first.
Oh, really? How so?
Well, when you hear explicability in tech, it sounds like a purely mathematical term. It sounds like dumping the raw algorithmic weights on a user's desk to prove exactly how the model arrived at a decision.
Right, the purely technical view.
Exactly. But Römer brilliantly frames it as a combination of 2 distinct concepts: intelligible weight, intelligibility, and accountability.
Yes. Intelligibility is about translating the mechanism. So can the system explain its output in plain, human-readable language that a non-technical stakeholder can actually understand?
Not just a bunch of math.
Exactly. But you're right, that alone isn't enough. Accountability is the operational guarantee. When the model inevitably makes a mistake, whose desk does the buck stop at?
Who actually owns it?
Precisely. Who is the named human responsible for the remediation? It shifts the focus from what did the machine do to who owns this outcome.
And that accountability piece seems to be the main fault line when you look at how different global frameworks approach governance, right? They all want accountability, but their personalities are completely different based on their regulatory cultures.
Yeah, that's a great way to put it. If you look at the EU Trustworthy AI Guidelines, they act very much like a strict legal guardian.
Very strict.
They categorize AI systems by risk level, and they focus heavily on lawful, robust systems with incredibly strong privacy controls. They are basically preparing for a world of litigation.
Yeah, contrast that with the IE framework.
Right, the Institute of Electrical and Electronics Engineers.
They take a much more mechanical approach, right?
Very much an engineering-first stance. I mean, they are the people actually building the hardware and software. So their framework requires interdisciplinary review boards, rigorous algorithmic audits, and adversarial testing baked right into the technical standards.
They treat ethics as an engineering problem.
Yeah.
Exactly, to be solved with engineering. And then you have the OECD, the Organization for Economic Cooperation and Development, which looks through a macroeconomic policy lens.
So more like diplomats.
Very much so. Their goal is to promote cross-border coherence across 47 countries, so that a multinational corporation can actually deploy an AI system globally without breaking local laws in every new market.
That fragmented landscape seems somewhat manageable if you're building a traditional, narrow AI, but generative AI and massive foundation models just completely break that paradigm, don't they?
Oh, they obliterate it. Older frameworks assumed you were training a model on a highly curated, highly labeled data set for one very specific task.
Right.
But foundation models are trained on vast oceans of unlabeled data using self-supervision, meaning the model learns patterns on its own without human tagging. And because they're so adaptable, they introduce entirely new risk categories.
Like hallucinations and copyright stuff.
Exactly. We are suddenly dealing with complex copyright claims based on billions of scraped images, malicious prompt injections where users trick the AI into bypassing its own security, and of course, hallucinations.
Let's actually talk about the mechanics of solving those new risks, because Römer doesn't just list the problems, he provides real mitigation strategies.
He does, yeah.
For hallucinations, the article highlights retrieval augmentation, or AB, and grounding. Instead of just dropping the acronym, how does ARG actually tether a model to reality?
So think of a standard language model taking a closed book exam.
Okay.
It's generating an answer by predicting the next logical word based on billions of data points it ingested months or years ago. It's essentially highly educated guessing, which is why it invents facts sometimes.
Right, it just wants to sound plausible.
Exactly. REG turns that into an open book exam. Before the AI is allowed to answer you, the system forces it to retrieve a specific, verified document from your secure internal database, read that document, and generate the answer strictly based on that text.
Oh, so it grounds the generative math in factual reality.
Exactly.
But doing that requires meticulous data provenance. You have to know exactly where your approved data came from in the first place.
Yes, and that becomes even more critical as global jurisdictions start diverging on what you're legally allowed to train an AI on.
Right, like Römer specifically brings up recent law changes in Japan regarding copyright enforcement. It basically proves you can no longer just scrape the open web and hope for the best.
No, absolutely not. You need an audited paper trail for every piece of data.
Mm-hmm.
But you know, all of this theory, the frameworks, the mitigation strategies, they only hold value if they fundamentally change how a business operates.
Yeah, it has to be practical.
Right. You have to look at what happens when these principles collide with real-world business objectives.
Which brings us back to that massive hiring algorithm failure we touched on at the beginning. How does a multi-million-dollar project accidentally learn to discriminate?
It happens because AI is inherently backward-looking. It optimizes for the patterns it finds in historical data.
Oh.
So in the case of that hiring tool, the developers fed it a decade's worth of resumes from successful hires. But historically, the tech industry has been heavily male-dominated.
Right, so the data reflects that.
Exactly.
Yeah.
The AI didn't understand the social context. It just recognized a mathematical pattern that resumes containing words associated with, say, women's colleges or women's sports clubs correlated with candidates who weren't hired in the past.
Oh, wow.
So it systematically downgraded them.
That is just a terrifying realization. Training an AI on historical data without rigorous fairness checks is essentially taking all the implicit biases of your past hiring managers and coding them into an automated machine that operates at lightning speed.
Yeah.
You aren't just making a mistake, you're scaling it. It's like hiring a prejudiced manager to train your entire HR department.
And the legal and reputational exposure from a failure like that is existential for a company. But, governance isn't just a defensive brake pedal.
Yeah.
No, when implemented correctly, it's a steering wheel that lets you drive much faster. The article highlights the healthcare sector, specifically radiology support tools, as a massive success story.
But the success there wasn't just because the algorithm was smart, right? It was because of the guardrails they built around it.
Precisely. Yeah. These AI systems successfully helped clinicians spot anomalies in medical scans significantly faster. But they only achieved those workflow efficiencies because governance protocols required mandatory human review, strict dataset audits, and very clear operational threshold.
Meaning
Rules for when the AI was confident enough to make a suggestion versus when it needed to defer entirely to the human doctor.
Ah, I see.
Ethical AI is a core performance driver. If your clinicians or your customers don't fundamentally trust the system, its technical capabilities are completely irrelevant. They just won't use it.
Yeah, I get the philosophical need for trust, but how does a business actually track that? Like, I can't put "be more ethical" on a Q3 earnings spreadsheet. How do you quantify these concepts?
You quantify them through highly specific key performance indicators that map back to those 5 core principles.
Okay, give me an example.
Let's take justice and fairness. Your metric there is tracking disparate impact. You don't just look at the model's overall accuracy, you segment the outcomes.
Break it down by demographic.
Right. If the model is 95% accurate for demographic A, but only 70% accurate for demographic B, you have a disparate impact failure. And you monitor those subgroup performance rates continuously.
Okay, I can see how you tracked demographic fairness, but robustness feels much harder to quantify. How do you actually put a number on how resilient an AI is against attacks or failures?
You measure it through adversarial hits and mean time to recovery.
Adversarial hits.
Yeah, so during development, you actively red team the model. You intentionally feed it noisy data, confusing prompts, or malicious code to see how many times it breaks or produces a harmful output. You count those hits.
Got it. And the recovery part.
Once deployed, you track the mean time to recovery. When the model does degrade or face an attack, how fast can your engineering team isolate the issue, restore a safe version, and patch the vulnerability?
Makes sense.
Furthermore, tracking SLA adherence service level agreements ensures accountability. When an incident is flagged, how many minutes or hours does it take for the named owner to investigate and remediate it?
Okay, so let's put this into a practical playbook. If you are listening to this right now, whether you're a lead engineer, an executive, or just a professional trying to navigate this new landscape, how do you actually implement this oversight on Monday morning?
The architecture of your oversight really determines your success. You have to build a cross-functional ethics board. A common mistake is siloing this entirely within the legal department.
Oh, for sure.
Centralized governance only works when you have engineering leads, product managers, legal counsel, and crucially, voices from the impacted communities all sitting at the same table.
Because a board made entirely of engineers will just have massive operational blind spots.
Exactly. Diverse voices make your decisions robust and defensible.
And that board needs to mandate privacy by design from the architectural level, right? I mean, Römer emphasizes that regulations like GDPR in Europe or CCPA in California shouldn't be treated as an end-of-pipe compliance checklist.
Absolutely not.
You have to build data minimization right into the code. Don't scrape 100 data points if the model only needs 10 to function.
Right. And you enforce strict role-based access controls, so only specific personnel can decrypt and touch sensitive data sets.
Yeah.
But managing all of those moving parts manually is impossible, which is why the tools of the trade are so vital. The article heavily advocates for the adoption of model cards.
I've heard model cards described as like a nutritional label for an algorithm, but that feels a bit passive to me. To me, it reads more like a heavy machinery spec sheet.
I like that.
Yeah, like if you buy a commercial truck, you need a document detailing the exact maximum towing capacity, the tire pressure limits, the engine tolerances, so you don't attach a load that literally snaps the axle.
That is a much more accurate way to look at it, honestly. A model card is standardized documentation that travels with the algorithm.
Right.
It explicitly lists the model's intended use cases, the exact data sets it was trained on, its performance metrics across different demographics, and its known limitations. It just removes the guesswork for any external partner or internal team trying to integrate that model into a new product.
And you pair those model cards with independent algorithmic audits to probe for data leakage. But for a large enterprise managing dozens of generative models simultaneously, how do you keep track of all those spec sheets and audits?
You transition to enterprise governance platforms. Römer specifically highlights solutions like IBM Watson X.governance.
Oh, right.
These platforms allow a company to centralize all those approvals, automate the monitoring of live models, and enforce lifecycle guardrails across the entire organization from a single dashboard.
Here's where it gets really interesting for me. What I appreciate most about the roadmap Römer lays out is how grounding the very first step is. If you're listening and feeling overwhelmed by the sheer scale of setting up a cross-functional board and enterprise platforms, you don't have to boil the ocean on day one. Step one is incredibly simple. You just take inventory.
Just figure out what you have.
Exactly. Just pull together a comprehensive list of the models and the data pipelines you currently manage. Classify them, and prioritize your governance efforts purely on the ones with the highest potential for operational harm.
Establish that baseline, and then recognize that governance is a continuous loop. You don't just run a fairness check in a staging environment on Friday and ship the product on Monday, never to look at it again.
Because real-world data is messy and constantly changing.
Exactly.
Like data drift.
Yeah.
A pricing algorithm trained on consumer behavior in 2019 is going to completely fail in 2022 because inflation and global events radically changed how people spend money.
Right.
The math didn't break, the world changed around it.
And that's exactly why continuous evaluation is paramount. You configure automated alerts for data drift and subgroup performance degradation.
So it flags you.
Yeah, if the model's accuracy starts slipping in a live environment, the accountable owner receives a notification immediately, allowing them to retrain the model before the drift impacts the bottom line. You're basically giving your engineering team standardized templates and playbooks so responsible choices become the default frictionless path.
Well, we've covered a tremendous amount of ground here. We navigated the chaos of 47 different policy blueprints, distilled them into 5 core principles, examined the severe business cost of biased historical data, and laid out a concrete playbook for continuous evaluation.
It's a lot, but it's essential.
It really is. But as we look toward the horizon of this technology, where is this tension heading next?
This raises an important question, and it's a tension that modern professionals will have to manage very carefully. It goes back to the dynamic between two of those core principles we talked about, autonomy and explicability.
Okay.
The framework demands that we keep a human in the loop to maintain human autonomy, but it also demands that AI systems become highly intelligible and capable of explaining their reasoning.
Right. We want the machine to show its work in plain English.
But consider the psychological effect of perfecting that explicability. As these systems get incredibly sophisticated at justifying their decisions in flawless, beautifully reasoned, and highly persuasive language, do we inadvertently surrender our autonomy?
Oh, wow.
Think about it. If an AI flags a medical scan or rejects a loan application and provides a highly convincing, logical explanation for why it did so, human operators may become incredibly complacent.
We just agree with it.
We might reach a point where our human-in-the-loop override systems become entirely ceremonial because humans simply trust the machine's perfect articulation over their own judgment.
That is a profound risk. If the AI is too persuasive, we stop double-checking its work, which completely defeats the purpose of having human accountability in the first place.
Exactly.
The machine might speak to us in one clear, compelling voice, but the ultimate vigilance and the burden of the final decision still rests squarely on our shoulders. The framework gives you the tools to build safely, but it cannot replace human judgment.
Well said.
Thank you for tuning in to the SmartKeys podcast. We really appreciate you joining us for this deep dive into the mechanics of responsible AI.
It's been great.
If you found this strategic breakdown valuable and want to stay ahead of the curve on the future of work and business efficiency, please make sure to subscribe to the podcast. And to get the complete step-by-step roadmap for your own engineering teams, I highly encourage you to read Felix Römer's full, comprehensive article. The link to the original piece is right there in the show notes. Go check it out, start taking inventory of your own models, and we will see you next time.